We already discussed about the importance of sampling. Now, let us discuss about one of the methods of sampling, which is random sampling. Random sampling is usually carried out when the area under study is fairly uniform, very large, and or there is limited time available. When using random sampling techniques, a large numbers of samples or records are taken from different positions within the habitat. A quadrat frame is most often used for this type of sampling. This is done many times at different points within the habitat to give a large number of different samples. In the simplest form of random sampling, the quadrat is thrown to fall at random within the site. However, this is usually unsatisfactory because a personal element inevitably enters into the throwing and it is not truly random. True randomness is an important element in ecology because statistics are widely used to process the results of sampling. Many of the common statistical techniques are only valid on data that is truly randomly collected. This technique is this technique is also only possible if quadrats of small size are being used. It will be hard or even impossible to throw anything larger than a 1 meter square quadrat, and even this might pose problems. Within habitats such as woodland, like forest or scrub areas, it is also often not possible to physically lay quadrat frames down because tree trunks and shrubs get in the way. In this case, an area the same size as the quadrat has to be measured out instead, and the corners marked to indicate the quadrat area to be sampled. A better method of random sampling is to map the area and then to lay a number grid over the map. A random number table is then used to select which squares to sample in, or you can use Excel or any computer generated software to produce any random numbers. For example, if you have mapped our habitat and have then laid a number of grid over it as shown here, we could then choose which squares we should sample by using the random number table. Many ecological surveys are carried out over extended periods of time, with sampling taking place at regular intervals within a particular habitat. In such cases, it is necessary to estimate the number of samples which should be taken at each sampling period. The minimum number of samples which should be taken to be truly representative of a particular habitat can be ascertained by graphing the number of species recorded as a function of the number of samples examined. I will show it in the next slide. Also, there are some mathematical formula to generate numbers of a number of samples. Okay, you can refer to the textbook for that, and you can also refer to previous research on the number of sampling or sampling sizes that the previous research has done. The graph here is an example. Okay, the first sample. Okay, if we look at the first sample, yielded uh, with 9 different species. With the second sample, a total of 13 species had been found. After 5 samples had been examined, the total species number had risen to 21. By the time 7 samples had been taken, no more new species were being found. So at this point, uh, further sampling is becoming unnecessary. This graph therefore shows us that for this particular habitat, we need to sample at least 7 samples in each sampling period. So further sampling will merely waste time and duplicate results. So next, we will discuss on systematic sampling.